This question asks, what Ke must an electron possess to have a wavelength comparable to the diameter of an atom? So diameter of an atom, right, roughly is around 10 to the power minus 10 meter. If you don't know this, right, then too bad. You can just skip this question. Don't need to do. So with this, right, we can form the equations. So we know lambda equals to h over p. And what's p? Ke is equals to p squared upon 2m. Okay, so p is actually equals to 2mk. Okay, so we put this in, lambda equals to h over square root 2mk. But we actually want to know what is the Ke. So make Ke the subject. So we'll have, right, h square over lambda square times 2m. Okay, so you substitute all these things in. So you know the mass of electron 9.11 times 10 to the power minus 31, so on. Okay, so just go and substitute. And you should get something that's close to option C. Okay. However, right, for this question, I wouldn't do it this way. Like for line spectra or for photoelectric effect, right, it will always be very helpful to know the energy of, for example, visible light photons, or like 1.7 to 3.1 eV. There are also some numbers we need to know at our fingertip, okay, for the de Broglie wavelength, okay, for electrons. A typical accelerating voltage, okay, that we will use, right, in the lab, okay, just remember this number is around 100 volts. This is a ballpark figure, okay, around 100 volts, because, right, you see your AC power supply, right, is 240 volts. So we use typically 100 volts. So this electron, right, what will be is Ke. Is Ke, right, will be equals to 1.6 times 10 to the power minus 19, okay, times 100. And that will equals to the p squared upon 2m. Okay, you can substitute the mass of electron, and then, right, you find what is the de Broglie wavelength. De Broglie wavelength for this 100 eV electron. This number, right, will turn out to be approximately 10 to the power minus 10 meter. Okay, I do not know the exact number. You can go and calculate it, but I remember this is the range. So 100 volts will give you 10 to the power minus 10 meter de Broglie wavelength. Okay, so this ballpark figure you should know, because in such a question, right, I don't even need to see whether is it 1.51 or 2.41. I simply look at the order, okay, and I could tell that it must be C without ambiguity.